Hi students, today I would like to explain how to solve numericals in physics. I will be posting a series of videos with explanation of solution of various numericals in physics. Today we will start with the lesson electricity. So what you have to do, you watch the video and understand the steps of the solution, and after that take your notebook and do the same question in it. This question, it is taken from your textbook, CBSE NCERT textbook, 10th standard, in page number 213. You can see the question here, that is, draw a schematic diagram of a circuit consisting of a battery of 3 cells of 2 volt each, a 5 ohm resistor, an 8 ohm resistor and a 12 ohm resistor, and a plug key, all connected in series. The second question is, redraw the circuit of question number 1, putting an ammeter to measure the current through the resistor and a voltmeter to measure the potential difference across the 12 ohm resistor. What would be the readings in the ammeter and voltmeter? So these two questions I merged into a single one, and you can see that on this screen. Okay, we'll start with the first part of the question, that is to draw a circuit diagram which consists of a battery of 3 cells of 2 volt each. So this is cell 1. The longer line is the positive of the cell and the shorter one is the negative, and the positive of a cell is connected to negative of the next one. So this is a battery of 3 cells with 2 volt each. So the total will be 6 volt. Okay. Then we have to connect a 5 ohm resistor, 8 ohm resistor and 12 ohm resistor in series. So the next connection I will do at bottom. First I am connecting a 5 ohm resistor, then an 8 ohm resistor, then a 12 ohm resistor. These all are connected in series. This is 5 ohm, this one is 8 ohm, and this is 12 ohm. These all are connected in series. Okay. And also we need a plug key in the circuit, so that I am connecting here a plug key. This is the first part of the question, to draw a circuit diagram of 3 cells of 2 volt each, so total 6 volt, and 5 ohm resistor, 8 ohm resistor and 12 ohm resistor all are connected in series. Now again, okay, now the second part of the question is to redraw the circuit diagram, putting an ammeter to measure the current through the resistors and also a voltmeter to measure the potential difference across the 12 ohm resistor. What would be the readings in the ammeter and voltmeter? Means we need to find the total current in the circuit and the potential drop across 12 ohm resistor. So first of all, I am going to introduce an ammeter to measure the current in the circuit, and you know that ammeter should be connected in series in a circuit. So I am using this area. You can connect anywhere in series in the circuit for measuring the current. So here we will connect the ammeter, and as you know, ammeter has a positive terminal and a negative terminal. and that positive of the ammeter should be connected to the positive of the cell and negative of the ammeter to the negative of the cell. And to connect the voltmeter across 12 ohm resistor to find the potential difference across 12 ohm resistor, you know that voltmeter should be connected in parallel. So here I am going to connect the voltmeter to measure the potential drop across the 12 ohm resistor. And for this voltmeter also, there is a positive terminal and negative terminal. So that positive of the voltmeter should be coming to the positive of the battery here, and negative of the voltmeter to the negative of the battery. Okay, now the circuit is complete. Now we can do the calculation here to find the ammeter reading and voltmeter reading. So ammeter reading means it is the current flowing through the circuit. For that we have a total voltage of the battery, that is V is equal to 6 volt is applied here, and we have 3 resistors. I am taking these 3 resistors as a resistor R1, it is equal to 5 ohm, and the resistor R2, I am taking it as 8 ohm, and the third resistor is 12 ohm, is taken as R3, 12 ohm. And since these resistors are connected in series, you know that if resistors are connected in series, the equivalent resistance of the combination will be the equivalent resistance of the combination. We can write is equal to R1 plus R2 plus R3. This will give the total resistance in the circuit. When we substitute the values, the effective resistance of the combination equivalent resistance is equal to, we have R1 is equal to 5 ohm plus 8 ohm plus 12 ohm, that is total is equal to 25 ohm. So this is the total resistance in the circuit, and the applied potential is 6 volt. So the current through the circuit we can obtain from the Ohm's law equation, that is I equals V by R. The voltage upon the total resistance of the circuit, here I should write equivalent resistance, the total resistance of the circuit. So that is equal to, we have a total applied voltage here 6 volt, and the total equivalent resistance we got 25 ohm. So the total current in the circuit is 6 volt divided by upon total resistance 25 ohm, that is equal to 0.24 ampere. So the total current in the circuit is 0.24 ampere. So that is the first part of the question. In the second bit, that is to find the ammeter reading. So here the ammeter reading is 0.24 ampere. The same current will be flowing through all the resistors 5 ohm, 8 ohm, 12 ohm. So you know that in series circuit current will be same, because there is only one path of electricity to flow. The same current 0.24 ampere is flowing through all the resistors. Now to do the second part of the second bit question, that is to find the voltmeter reading, here we have a 12 ohm resistor and voltmeter is connected parallel to that, and we know that the same 0.24 ampere is flowing through all resistors. So in 12 ohm resistor also the current flowing is same 0.24 ampere, and the voltage drop we can find out, the voltmeter reading across 12 ohm resistor we can find out by using the Ohm's law equation. V is equal to I into R, the current into resistance. But here remember, we have to take the resistance only this 12 ohm which is coming across the voltmeter, and so the voltmeter reading here will be is equal to 0.24 ampere into the resistance 12 ohm, that is equal to, it will come as 2.88 volt. So out of the 6 volt of the battery, this 2.88 volt is dropped across the 12 ohm resistor. That much is the question. But here we can find out the voltmeter reading if it is connected across the 5 ohm resistor, 8 ohm resistor, etc. So I'll take this third resistor 12 ohm and its voltage drop across it as V3. Okay, so if I find it for V2, that is for 8 ohm resistor, the voltage drop across, or the voltmeter reading across 8 ohm resistor will be the same current 0.24 ampere into 8 ohm into 8 ohm, that is equal to 1.92 volt. So 1.92 volt will be dropped across 8 ohm resistor, and we can find it for the first resistor, that is taken as R1 equal to 5 ohm. So for that I am taking the voltage drop as V1 for example. So here also current is same, 0.24 ampere, and its resistance is 5 ohm, that is equal to 1.2 volt. This will come 1.2 volt. Now we can see one thing here. When we add the voltage drop across these all resistors, say 5 ohm, 8 ohm and 12 ohm, the total will be equal to the applied voltage here. That is, in series combination, current will be same for all resistors, but voltage will be different. The total voltage applied will be equal to sum of the voltage drop V1 plus V2 plus V3 across each resistor. So here when we use the values, the total voltage in the circuit will be V1 we got here 1.2 volt for 5 ohm resistor, plus V2 we got 1.92 for the 8 ohm resistor, and V3 we got here 2.88. The total voltage we can see here on adding all these three, 8 plus 2 10 0, and here again 9 plus 2 11, 11 plus 8 19, 19 plus 1 carry 20, so 0 again, 2 remaining, 2 plus 1 3 plus 1 4 plus 2 6, means 6 volt. That is the total applied voltage of the battery. So what we can see here, the voltage is divided among the resistors according to the resistance value. We can see here the highest resistor 12 ohm, it got 2.88 voltage drop, and the next below one, this 8 ohm resistor, it got 1.92 voltage, and the 5 ohm, it is the smallest value of resistor in this combination, that got 1.2. So in series combination of resistors, we can see the voltage drop will be as per the value of resistors. The highest resistor will get the maximum voltage drop, and the lowest one will get the minimum voltage drop. When we add the voltage drop or the potential difference across each resistor, we'll get the total applied voltage. Okay, now you revise the same once again and try to do that in your notebook. then you can try the next video I'll be posting after this.